Welcome to another Grade 10 Life Science session. Today's focus is going to be on the history of life, one of the topics related to diversity, change and continuity. Let us now focus on some of the key areas that you need to know in this session. The key concepts for this session will be some of the terminology and definitions related to the history of life, life's history, the mass extinctions, the key events in South Africa as part of the history of life, as well as the importance of fossil tourism. We now look at the geological time scale. We need to focus that the geological time scale is actually a chart showing you the major key events in the history of life. Now let us look at this chart and look at the importance events as well as the plants and animals that form part of the geological time scale. What is the geological time scale? Remember, the geological time scale divides the major events of the Earth's history into manageable time periods. Let's look at it. You have the time scale here, and you can see the different periods which we're going to focus on a little later. Now, the details of the geological time scale need not be memorized. Only certain parts need to be memorized. Let's look at the eons. What are eons? Eons are the longest time periods on a geological time scale. That is the Archean and the Phanerozoic. Let's plot them on the geological time scale. You find that the very beginning of Earth's history started in the Archean. That's the longest time period. And then the rest of the geological time scale is divided into the Phanerozoic. These two eras, the Archean and the Phanerozoic, are the two main eons which divides the geological time scale. They are the longest time periods. We then have these two eons divided into the three eras. Now learners, you do need to know the names of the three eras into which the eons are divided. Let's have a look. You need to know that it is in the Archean eons that we have your pre-Cambrian. This is your pre-Cambrian era. That's your pre-Cambrian era. And what it is characterized by are your vast number of invertebrates, or you find that the bacteria or your prokaryote, the very early prokaryote, were actually characterizing the pre-Cambrian era. Then you have your Paleozoic era. Now this is the Paleozoic era. It's the first era, this one here. That's the Paleozoic era. Then comes the Mesozoic era, and then comes the Cenozoic era. You need to know the names of the it's the Paleozoic era, the Mesozoic, M for Mesozoic, M for middle, and then the century that we are in now, this is actually the Cenozoic era in which we are living. And before life actually started, the formation of the Earth's crust was actually part of the pre-Cambrian era. Right, here are some pictures of the animals that existed in each era. You do not need to know the actual names of the periods of each era. You do not need to know the actual names, but we will focus on the names of Ordovician, Devonian, Permian, Triassic and Cretaceous later. When we actually discuss the mass extinctions, we will focus on some of the important periods in which mass extinctions took place. But you do not need to know the actual eras, the actual periods of each era. Please remember that. Now let us look at the next part of the life's history on Earth. Remember, eons are the longest time periods on the geological time scale. The two eons are the Archean and the Phanerozoic. The Archean is characterized by bacteria and algae. Remember bacteria and algae? Bacteria forms part of your prokaryote, which we had discussed under biodiversity and classification. Your algae and fungi also forms part of the Archean, and therefore they are the microbial or the microorganisms that existed in the Archean era. The Archean, the eon, the actual Archean means the primitive life. Now we look at eras. Eons are divided into smaller time periods called eras. It's the Precambrian era, the Paleozoic era, and the Mesozoic era. Now we're going to see what does Precambrian, Paleozoic, Mesozoic, and Cenozoic actually mean. The Precambrian is actually when the Earth first began, before the diversity of life. The Paleozoic is actually your ancient life. The Mesozoic is the age of the reptiles, and your Cenozoic era is the age of the mammals where we are now living. We're now going to, what is the importance of a geological time scale? Remember that the geological time scale actually puts in the life's history of Earth, the history of life on Earth, into manageable time frames, into manageable periods. The Earth actually began 3.5 million years ago. So although the Earth is 6.5 million years old, the history of all the events of life on Earth can be dated back to about 3.5 million years ago. Let us look at some of the important things that you need to focus on. The periods. Remember that periods differ in length. That is the Ordovician period, the Permian, and the Triassic. Do not need to memorize the names of these periods, but actually what we need to know is that the eras are divided into periods of different lengths. What is the meaning of the word extinct? This biological term means that the animal no longer is in existence. Its life has ended or it has died out. Another term that you need to know in this section is what is a fossil. Remember that traces of organisms which used to be alive, that have hard tissue, such as bones or shells, fossilize better than the softer parts of the animal. Soft tissue is eaten or it decays or decomposes after death. Therefore, remember that there could be gaps in the fossil records. We may not know of certain organisms that existed because if they were soft-bodied and they could not fossilize due to climatic conditions, they will not be recorded. So there has been gaps in the fossil record due to soft-bodied animals, but we do have imprints of soft-bodied animals that can form part of fossils, which we can look at later. Leaving the bones behind and the shells to petrify, turn into stones. Scientists who study fossils are called paleontologists. Now remember that a paleontologist differs slightly from a geologist. Paleontologists actually study the fossils found in rocks, whereas geologists basically study the rocks itself, the formation of different rocks. Now what you need to know, learners, is what does the word petrify actually mean? Petrify means when a hard part of an organism actually becomes encrusted with the calcium carbonate from the rocks. So once the calcium carbonate and the mud gets into the shell or into the bone, it becomes hardened or petrified, and that becomes a fossil. We cannot be called fossils because we exist at the present time, so all the human bones lying in the graves are not called fossils. Fossils are formed over millions of years. So basically fossils are Bones are hard remains that have formed over millions of years. So the hard remains or the bones of a skeleton of somebody who died maybe 3 years ago, we cannot call that a fossil. But if it's over millions of years old and maybe no longer exists, we can regard that as a fossil. Let us now look at stromatolites. These are blue-green cyanobacteria, which forms a film over the mud in shallow saline waters in West Australia. They're responsible for almost all the oxygen that was present in the atmosphere when there was no plant life. Stromatolites are almost extinct due to man polluting the seawater. Traces of fossilized stromatolites was found in Barberton in Mpumalanga. Now let us look at what are stromatolites. Basically, stromatolites are a bluish-green alga which actually forms a film in the muds of saline water. What is saline? Saline means the salty sea water. If you have to go, for example, to Mauritius, you see these microbial mats in certain parts of Mauritius untouched by man. So these microbial blue-green mats are actually stromatolites which actually release oxygen. In fact, it is the stromatolites that were responsible for the vast amounts of oxygen that was present on Earth's atmosphere before the Paleozoic era began. So before that explosion of life, before the Cambrian explosion, what gave rise to the Cambrian explosion? If there were no trees, if there were no plants photosynthesizing, how did life actually begin? And it is noted that it is due to the stromatolites that were found in the shallow saline waters, example of West Australia, that began to give most of our oxygen found on Earth today. Let us look at a picture of the stromatolite. Here are these stromatolites. You can see that they are like mud casts, and within the films of mud there's cyanobacteria, the blue-green cyanobacteria, then there's a mud, then the cyanobacteria and the mud, and from a high view from the sky, they will actually look like blue-green mats. Blue-green mats. Microbial mats. Microbial mats. And oxygen is being released into the atmosphere from these stromatolites. We now go to the next definition. The Cambrian explosion is the first of the Paleozoic era. It's the first time period in the Paleozoic era. And what is it characterized by? An incredible diversity of life appeared on Earth due to the abundance of oxygen released by the stromatolites, that is the blue-green bacteria. Origins of early forms of all animal groups. What are some of the animal groups that emerged during the Cambrian explosion, where most of your fish and your mollusks, which is your snails, your ammonites and your bivalves, have actually formed in the Cambrian explosion due to the abundance of oxygen. So most fish and marine life actually was formed in the Cambrian explosion. Soft-bodied animals were formed in this time period in Namibia. So we also have soft-bodied animals such as the earthworms that were formed on the snails that were formed in the Cambrian explosion. And some of these fossils, the fossil remains of the soft-bodied animals were found in Namibia. Namibia is part of Africa. So in Africa, you have Namibia, where we can actually see fossils of the very first fossils of the soft-bodied animals. We go to radiometric dating. This is a very important concept that you need to know. It uses the radioactive material in rocks to determine when rocks were formed or the age of the rock. The radioactive elements in the rocks slowly decay over time, known as radioactive decay. Now, radiometric dating is a method used to determine the age of a fossil found in a rock. And they do it because these fossils have either carbon, or you can also have uranium, which actually decays over time. And by looking at the decaying period, they can determine the life or the age of the fossil. We look at other concepts that you need to know, which can be confusing with radiometric dating, and that is relative dating. Remember, radiometric dating, carbon dating, and uranium dating refers to one and the same thing. It is a method used to determine the age of a fossil by looking at the decaying time of the uranium or carbon within that fossil. Now let's look at relative dating. Relative dating looks at the comparative depths of the fossils in rocks to ascertain which are the oldest and which are the most recent. Now, if you have layers of rock, and for example, if there's a fossil found in rock layer 1 and there's a fossil found in rock layer 3, it means that the first layer at the bottom, the layer at the bottom, is the oldest fossil. And the layers on the top is one of the newest or the most recent fossil. So you're comparing the depths of the fossils to analyze which fossil came before the other, and that is why we talk about relative dating. So relative dating means relative to the other fossils, which one has come first and which one had come later. So if you look at the depths of the rock in which fossils are found, it also tells you a very important thing, that fossils are found in sedimentary rocks. Sedimentary rocks are rocks that are made up of layers. They are never ever found in igneous rocks. Please remember that. Let's look at more concepts. Right, life's history now. Remember that the Earth is 5 billion years old. Okay, 5 billion years old. In some textbooks, you can say that the Earth is 6.5 billion years old, but it ranges between 5 to 6.5 billion years old. Remember, there was no one that existed at that time to know exactly when the Earth actually began, when that explosion started. So the Earth is 5 billion years old, but the history of life, the history when man began to record, the history of life according to fossils began almost 3.5 million years ago. Now, how can one actually ascertain that the history of life, where life actually began and the key events recorded, started 3.5 million years ago? By looking at the age of fossils, scientists and geologists can actually ascertain or infer that looking at this fossil, we can say that life on Earth started at 3.5 million years ago. Let's look at the continental drift. Right, the continental drift is all the continents were joined as one big landmass called Pangea. Please look at the spelling, it's P-A-N-G-A-E-A. So one landmass called Pangea, which began to break into smaller continents, making wider oceans and more place for marine life. Now, continental drift, if you look at the map of the Earth, it seems as if you take all of them together, all the continents together, put them together, like it will fit like a puzzle into one big picture. Now that one big picture, putting the continents together, was one big landmass called Pangea. Then the Pangea broke up into the northern and the southern parts. The northern part called Eurasia, and then the southern part called Gondwana land. Now, what was the actual reason for the continents splitting up or breaking up? The main reason was due to volcanic activity that occurred beneath the plates of the earth. So beneath the plates, you had this volcanic activity that began to separate the continents centimeter by centimeter every year. Up till now, we find that our continents are still moving about a centimeter apart. You can hardly see it, but over a longer time period, we are able to take pictures from previous slides and then compare them, and you can see that the continents are indeed moving. Right. When the continents moved, we created wider oceans and place for marine life, more marine life. South African examples of continental drift include the discovery of fossils of marine organisms in places that are very far from the sea, such as the bivalves and the ammonites in the Makatini Flats in the northern KwaZulu-Natal, and the marine trilobite fossils in the Karoo. Now, please remember, we need to know what are some of the fossils that can be identified to tell us, look, there had been continental drift. What evidence do we have that the continents are moving? And we find that if there's an ocean and the land on the either side of the ocean, you find that there are fossils of organisms that exist on one side of the ocean and on the other side that are the same. So that tells you that at one time the land masses were together and now they've been separated, and now a sea or a geographical barrier has separated them, and therefore you find same kinds of fossils very far from the sea. And that shows you that the continents have separated. Let us now look at an example of an ammonite fossil. Here is an ammonite fossil. You can actually see the shell, which is actually hardened or petrified with the calcium carbonate. And here is a trilobite fossil. And this is actually the imprint. A trilobite has a very soft body part, and then its outer crust, which is the exoskeleton, left an imprint on the sandstone or the mud, and that tells you that this invertebrate is a trilobite, which is characterized by your Paleozoic era, and your ammonite is also part of the Paleozoic era. We now take a break, and when we come back, we will actually look at mass extinctions. Welcome back. We now look at mass extinctions, which you need to know in the history of life. Mass extinctions. There were 5 mass extinctions. Now this may be a bit difficult for you to understand, but remember, for the mass extinctions, you can make a mnemonic to remember the names. Right, and we're going to start off with the first one. It's the O, which means Ordovician, the D, which means Devonian, the P, which is the Permian, the T, Triassic, and the C, which is the Cretaceous. Now you can make a mnemonic to remember the 5 mass extinctions. The first one was the Ordovician one, and you can say, for example, our dads paid taxes crazily. That is my way of making a mnemonic. You can make your own in order for you to remember the 5 mass extinctions in the correct order. You need to know them in the correct order. So O for Ordovician, what exactly happened in the Ordovician mass extinction? What was the cause of, so you need to know what is the cause of the Ordovician mass extinction, and what are the animals basically that died off in this period. So in all 5 mass extinctions, you need to know the cause and the animals that died off very, very briefly. Let's have a look. The Ordovician mass extinction is caused by climate changes, and many trilobites became extinct. Remember, your trilobites belonged to the arthropods. They were small invertebrates with a hard shell-like structure, and they were your trilobites. They were part of the Paleozoic era, and most of these trilobites died off because of the Ordovician extinction caused by great climatic changes. Let's look at the Devonian. This is where the ice ages or the global cooling and glaciation took place. Almost all of life forms died out. So in the Devonian period, which is part of the Paleozoic era, all your trilobites, your algae, your fungi, and most of the early forms of animals, like the fish, had died out in the Devonian period. And the cause of most marine life dying out was that it became very, very cold. So there was intense global cooling. It was the age of the ice ages. If you've seen the cartoon Ice Age, do you remember when they found the saber-tooth kind of a lion that existed in those days? They actually found the saber-toothed lion embedded in the Ice Age, and that's how they made the cartoon Ice Age. So we had a saber-toothed lion that actually died out because of the extreme cooling of the earth. So Devonian period is caused by the extreme cooling of the earth, and most marine life forms the fish had died out at that stage. Right, let's look at the next one. This is the Permian mass extinction. This is the most severe of all the mass extinction, and it was caused by great volcanic eruptions. Now, the actual Permian period is the greatest mass extinction. It lasted for a very long time, and therefore most of the gymnosperms and your vertebrates, your reptiles, your amphibians, the frogs have died out in the Permian period. So the Permian period was caused by massive volcanic activity. So the Permian period was caused by massive volcanic activity. In fact, most of the rocks that we see now are igneous rocks that we see, where you have your new infrastructure of the roads, and they are busy drilling and removing and excavating those rocks. They are hard. Those igneous rocks are due to the volcanic activity that took place in the Permian period, and it killed almost all life on Earth that existed at that time. And obviously most of the animals that died in the Permian period couldn't be fossilized, because remember, the lava was too hot and therefore burnt even the hard structures, the shells and the bones. Therefore the Permian period caused most of the phyla to become extinct. Let's look at the next extinction, the Triassic extinction, and it's caused by acid rain and the drops in the oxygen levels in the water. More marine life forms were destroyed. So the Triassic period is now the beginning of the Mesozoic era. So the beginning of the Mesozoic era, and that's where most of your reptiles were formed, and most reptiles died off in the Triassic period. What was the cause of the mass extinction in the Triassic period was just before that. Remember, before the Triassic extinction was the Permian mass extinction, where there was volcanic activity. Now all that ash and all that smoke that was released in the Permian period was still present in the atmosphere, and all the sulfur that came off from that volcanic activity actually combined with some of the water vapor to form acid rain. And this acid rain in the Triassic period, together with a drop in the ocean levels, together with the driving out of the oxygen in the water. Remember, it became very, very hot after all that volcanic activity, and the heat drove out the oxygen from the waters, killing the fish, killing the reptiles, and killing the amphibians as well. So the Paleozoic era started off with the Triassic period, the Mesozoic era. I'm correcting you. The Mesozoic era began with the Triassic period. Right, and it is in this Triassic period whereby the oxygen levels were low in the water levels of the seas dropped, acid rain, and therefore there was a big extinction in the marine life. Right, and remember, the Triassic period forms part of your Mesozoic era, the beginning of the Mesozoic era. Right, here is your Triassic, caused by acid rain, and more marine life was destroyed. We now look at the Cretaceous period. The Cretaceous period was characterized, that is the fifth mass extinction, which was about 65 million years ago. And it is in the Cretaceous period that we had actually our dinosaurs. And the dinosaurs and most reptiles and forests and ferns, or the gymnosperms, which were the cone-bearing trees, most of the cone-bearing trees together with your dinosaurs had died out in the Cretaceous period, the fifth mass extinction. Why? What caused the mass extinction in the Cretaceous period? And that was because of the asteroid impact. An asteroid or a comet was actually landed onto the Earth, and this created volumes of dust, clouds of dust, which blotted out the sunlight, preventing photosynthesis. Therefore, no trees could photosynthesize. All the dinosaurs that could feed on the trees died out because there was a shortage of trees. The trees died, no oxygen, no food, no oxygen, killing all the dinosaurs in the Cretaceous period. So the Cretaceous period also belonged to the Mesozoic era, and that is a period whereby all your dinosaurs about 65 billion years ago had died out. Okay, we are now heading for our sixth mass extinction. Yes, learners, we are presently part of the sixth mass extinctions. On a daily basis, if you look at it on news, we have examples of people that are illegally hunting, overfishing, illegal poaching. The pollution is all causing our biodiversity to become unsustainable. There will be nothing left for our future generation if man actually continues to destroy the wide biodiversity that's put on our earth for us. So what is the sixth mass extinction? The sixth mass extinction differs from the rest of the five, whereby the Ordovician, the Devonian, the Permian, the Triassic, and the Cretaceous, these five mass extinctions were caused by natural factors. Asteroid impact, volcanic activity, climatic changes, global cooling. These are all natural factors that resulted in the five mass extinction. But what is causing the mass extinction of the elephant, the blue whale, the dodo, our rhinos? Very few rhinos are actually left. Almost every month since the beginning of the year, rhinos have been poached in large numbers. There's been overfishing, whereby large volumes of fish have been netted and caught due to the increase in population, and that's decreasing our biodiversity, whereby in a few years' time, we wouldn't see certain fish. In fact, we have already have some of our fynbos in the Western Cape. The fynbos is endemic to the Western Cape. Even some of them have now, some of the species of the fynbos have become extinct due to the illegal fires that people light on the Table Mountain. That is causing the fynbos to become extinct. So the mountain zebra, some species of the mountain zebra have become extinct due to killing them for their hides, as well as the veld fires killing the mountain zebra in the Western Cape. Now let's look at some of the things that are causing the sixth mass extinction. We are now in the crisis of the sixth mass extinction caused by human activities such as illegal veld fires, which consume large amounts of valuable oxygen and release smoke and carbon dioxide, resulting in global warming and climate change. Illegal hunting, that is your rhinos, and habitat destruction due to the formation of new infrastructure. We're destroying most of the habitats of organisms that live in an area. Right, so We are in the process of the sixth mass extinction. Many species of phyla have already been lost. And to prevent a complete mass extinction of many other species, we have to become aware that there has to be laws and legislation, environmental laws, which we need to abide by. And if we abide by those laws, we can actually sustain our biodiversity in future. Right, let us look at some other very important concepts that you need to know. There are missing links. This is an example of an Archaeopteryx, and this Archaeopteryx is an animal or a reptile that is more bird-like and reptile-like. So it has reptile and bird-like features, and therefore they say that the Archaeopteryx is a link between the dinosaurs and the birds. Because it resembles a reptile and it looks like a dinosaur and it also looks like a bird, they say that this is the link between the dinosaur and the bird. The species that may have existed between the dinosaur and the bird was the Archaeopteryx. Right, so that's a missing link that you need to know. Then you have the coelacanth that you need to know about as part of the history of life. And the coelacanth is known as a living fossil. Now, what is a coelacanth? It's more of a cartilaginous fish that actually had small, short legs. With bluish scales. It had short legs below its pectoral fins, below its pectoral and pelvic fins. Short little legs, which means that it could have walked on land and it could swim, which means it could have been terrestrial as well as aquatic. So it was a huge fish. The name was a coelacanth, but why now will it be called a living fossil? Right. Initially, scientists believed that there was no traces of the coelacanth. There were imprints of it in the fossils of rocks found in the seabeds, and then they could not find it until 1938, when one of the scientists from the East London Museum had actually found a coelacanth in the waters of the East London. A second coelacanth was found in the waters near the Comore Island. And therefore, if scientists declared that a particular animal had been extinct and after millions of years re-find it, it's now become a living fossil. So the coelacanth is regarded as a living fossil because they thought it to be extinct, and now it has been rediscovered as early as 1938. We're now going to focus on what are some of the key events that you need to know that are important of the history of life in South Africa, the key events in South Africa that form part of the history of life on Earth. And we need to know that, remember, South Africa is actually known as a heritage site because of its wide biodiversity of plants and animals, the beautiful beaches. So the 3 Bs, it has a great amount of biodiversity, beautiful beaches, as well as a variety of the 7 biomes. So out of the 7 biomes, South Africa has the greater number of the biomes. In fact, I think almost all the biomes are found in South Africa. So out of the 7 biomes, 7 out of 7 biomes are found in South Africa. It has beautiful beaches with a wide diversity of marine life, and as well as a great biodiversity in the terrestrial ecosystems that are found in the Western Cape, like the Cape Town, the Protea, the Fynbos, which we had actually discussed under biodiversity and classification. Now let us look at some of the key events which you need to know for exam purposes. The stromatolites, remember, the cyanobacteria, which formed part of the Archean time period. Those were stromatolites, and where do we have fossils to say that we had stromatolite? We do have stromatolite fossils found in Barberton, and this was in Mpumalanga. In Mpumalanga. So if you go to Mpumalanga, in a town called Barberton, there are fossils of stromatolites that existed in the Archean period. We also have in Namibia, which is part of Africa, fossils of soft-bodied animals that we found. We have in KwaZulu-Natal, Mooi River and Escort, that forms part of KwaZulu-Natal. We have ancient plant fossils, or fossils called the Glossopteris. You need to know that the Glossopteris are leaf-like plants which are ancient. We no more find the Glossopteris. The Glossopteris actually belonged or looked like some of the fern species, but they no longer exist. And they were found in Mooi River and in Escort, and it was an ancient plant species. The coelacanth was rediscovered by the East London Museum in 1938. Remember, East London is also part of South Africa, and therefore we have rediscovered the coelacanth in the waters or in the seas of the East London. Mammal-like reptile fossils were found in the Karoo. They have advanced palates and complex ear bones, unlike true reptiles. They are called therapsids. Now, one of the therapsids is called the Thrinoxodon. Let us put it here. Thrinoxodon. The Thrinoxodon, you don't need to know the name, just to spell it again. The Thrinoxodon. Right. The Thrinoxodon was a therapsid found in the Karoo, which is also part of Africa. So that Thrinoxodon was more reptile. It was like more, had reptile features and also mammal-like features. So that is a therapsid that was found in, the fossils of the therapsid was found in the Karoo. We also had whale-like fossils of whales actually found in the Sahara Desert. And that tells you that if there were whales found in the Sahara Desert, life on Earth, we had more waters millions of years ago. We had more water, and then the sea levels gradually began to drop. So if fossils of whales were found in the Sahara Desert, it means that when life on Earth began, there was more water, more marine life rather than terrestrial life. Let us look at more key events. Mammal-like reptiles were found in the Karoo, and they were different. In fact, reptiles normally, true reptiles do not have ear bones, but these therapsids had large ear bones and large palates. Right. Dinosaur fossils can be seen in the Drakensberg and the Maluti Mountains. So most children are very fascinated about seeing a dinosaur. So actually, children, if you visit the Drakensberg or the Maluti Mountains in the KwaZulu-Natal area, you can actually go and visit the fossil sites in KwaZulu-Natal where there are fossils of dinosaurs that have been found in the Maluti Mountains and in the Drakensberg Mountain. So dinosaurs did roam around in the mountains in our country, Africa as well. So remember the Drakensberg Mountains near KwaZulu-Natal? So if you go there were actually dinosaurs that used to roam around. Let's just look at more key events. Pre-human fossils like the Australopithecus has been found in the Sterkfontein caves. Remember, in our earlier session we had spoke about biodiversity and classification, where we actually looked at the different sites where fossils could be found. And then we spoke about the cradle of humankind, where most of the fossils like Mrs. Pless, the Tuang child and the little foot, and then the Australopithecus sediba or Karabo was also found in the Sterkfontein caves near Pretoria. So therefore we have pre-human, our primates. There are also fossils found in the Sterkfontein caves, which is part of South Africa. Learners, what you need to know as well for the exam purposes is to locate the main areas where coal deposits are found. Now you may ask yourself, why do I need to know where coal deposits are formed if we are studying the history of life on Earth? Remember that coal is a fossil. It's a carbonized fossil formed from the millions of trees that were formed in the Paleozoic and the Mesozoic era. So all your forests and your gymnosperms and your cone-bearing plant, they were massive forests that were dominant in the Mesozoic era. And when these dominant plant life, that is your ferns and your gymnosperms and your cone-bearing plants, which are part of the gymnosperm, when all of them died out during the volcanic activity in the Permian period, when they died out and they were buried under rocks, remember, under the sedimentary rocks, all the trees died and they were buried. And as they were buried, they became hardened. They hardened to form coal. So all the carbon that was actually trapped in the tree trunks during photosynthesis, all the organic compounds that were trapped formed fossils called coal. Right, we now need to see what is the importance of fossil tourism. How does fossil tourism play a role in our country? Remember, with our rich biodiversity, beautiful beaches, and a variety of the biomes, you find that many people outside South Africa as tourists visit our country to visit the fossil sites and the beautiful beaches. By coming into the country, we not only get a lot of visitors, but they also provide a source of income which our country can use to make our infrastructure a better better for our people to live in, to provide better education. So fossil tourism is very, very important. Right, let us see some of the sites that are important in South Africa that serve as a source of fossil tourism. South Africa has a number of fossil-rich areas which attract tourists year by year. The cradle of mankind, you could have been to the Sterkfontein Caves, cradle of humankind, right? The Sterkfontein Caves near Pretoria, and you could have seen these pictures of our primates, which are actually made of wax, right? And they put in there from the fossils. Maropeng, which is also called the cradle of humankind. It's a Swana word for the origin of mankind, or where we once lived. So this tells you that in Sterkfontein, if there's a rich amount of fossils that are found in Sterkfontein Caves, our primates were found there at the beginning. That's where we once lived. That's why it's called the Maropeng. The fossil sites provides a source of income and employment in a town or country. Remember, we also have the Karoo Park in the Western Cape, right? The Karoo Park in the Western Cape also has a variety of dinosaur fossils and soft-bodied animals which can be viewed. So if people go to Cape Town, which is a great tourist attraction, they're able to see the fossil sites in the Western Cape, the Karoo National Park, and that's where they can see fossils of ammonites and bivalves. If they go to KwaZulu-Natal, they can see fossils of the dinosaurs, they can see fossils of the Glossopteris. Okay, and you can also see fossils of the soft-bodied animals that we found, for example, in near KwaZulu-Natal. Right. Now, learners, we're going to have a look at some of the questions. We're going to have an ad break, and then we're going to look at some of the important things that you need to know that can come in an exam on the section on the history of life. Welcome back. We are now going to look at some of the questions relating to the history of life. The first part that we're going to look at are multiple choice questions, and thereafter we're going to look at longer questions. So now let's have a look at the way we can answer the multiple choice questions. Question 1. Remember, when you are answering, you've got to write down the letter of the most correct alternative and do not write down the actual answer. Which of the following fossils, please underline the key that you need to know in order for you to choose the right answer. Which of the following fossils, so we need to look for a fossil found in Namibia. So we're looking at a fossil found in Namibia, and remember that was the soft-bodied animals, so the answer will be in your answer book 1.1.1 and the answer will be C. Right, let's look at the next question. We're looking at the importance of stromatolites. Learners, please remember you are given 4 alternatives. One has to be correct. The correct answer is always linked to some of the key words in the question. Look at the question easily, the answer is there. So the key words in the question will give you the answer if you have learnt your work. So the more you read, the more you read, and the more you read, and the more you read and underline, you will be able to get full marks in your exam paper. Let's look at the next question. The importance of stromatolites. Remember in your mind now, stromatolites are blue-green algae which release oxygen. So immediately, if you say they were trapped in the sediment, that is incorrect because that cannot be an importance. They are the closest to the modern plants, that cannot be an importance. They absorb oxygen. If they absorb it and cause animals to be poisoned, it cannot be an importance. But because they released oxygen into the air, that is important. Therefore, your answer there will be 1.1.1, 1.1.2. 1.1.12 is going to be, it's going to be A. Right, oxygen is very, very important. Remember, do not light illegal fires to burn down the dry grass. If you see of people doing that, do not advise them, do not burn the grass. It's important, it's part of nature, it will take care of its own. If you burn the grass, you're going to consume all the oxygen. Now remember, all the stromatolites that existed in the Cambrian, during the Cambrian explosion or the pre-Cambrian time, had actually died out now because of the pollution caused by smoke and water pollution. So the stromatolites were very, very important, and there's very few that exist now. They are responsible for giving us life. The oxygen that we're inhaling now not only comes from the plants, but they also come from those important microbial mats found in the shallow saline waters. Remember all these facts when you are answering your questions. Let's look at the next multiple choice. A problem in determining the accuracy of radiometric dating. So we're looking for a problem to determine radiometric dating. For radiometric dating to be accurate, there was a problem in causing its accuracy. Scientists are not sure, so that can't be a problem if they're not sure that the radioactive decay actually occurs. The decay rate of the minerals can change without warning. Right, that cannot be a proper problem in determining the radiometric dating. The rocks that contain the fossils can't be dated. Now you can see dating and radiometric. So the rocks that contain the fossils can't be dated. So that keyword dated and dating tells you that is the most appropriate problem that deals with that question. So the answer there would be C. So 1.1.3, your answer in your answer book will be C. The rocks that contain the fossils can't really be dated. Continental drift. Right, accounts of the fact that people have found fern-like fossils that got nothing to do with continental drift. The fossils of the subtropical plants in Antarctica. Accounts of the fact that people have found the fossils of subtropical plants in Antarctica. That could be a possibility, but let's look at the others as well. tectonic plates under the continents. If there's plates under the continents, it doesn't tell you that there's continental drift. And the fact that they're saying people have found, it doesn't go with this about tectonic plates under the continents, okay? Trilobite fossils in almost all the continents. So if they were found in almost all the continents, that doesn't really indicate that there was a drift. But the fact that the continents drifted, and you can find fossils in Antarctica. Now remember, Antarctica is an ice-like region right towards the poles. So if fossils can be found in a polar area where there's only ice, it means that these fossils have actually moved towards that area. Therefore, the finding of fossils far from the sea, remember, is an indication or evidence of continental drift. So the answer here is B. 1.1.4, B, and that is the fossils of subtropical plants, which are normally in a terrestrial area, is now found near the polar regions or near the Arctic region, Antarctic region, where there's only ice. Right. Which statement below does not apply to the Paleozoic era? In order for you to answer that question, you need to know some of the key events that happened in the Paleozoic era, which started off, remember, in the geological time scale, from the Cambrian to the Permian. The Cambrian period to the Permian period. So that was part of the characteristics of the Paleozoic era. So let us see what happened there. Trilobites and algae were dominant life forms. Yes, there were trilobites and algae in the Cambrian explosion, which was part of the Paleozoic. Remember, your bacteria and fungi were part of the Precambrian. But once the Cambrian started, which was the beginning of the Paleozoic era, they were algae and trilobites. So it is characteristic of the Paleozoic era. Therefore, we can tick it. Coal swamps were found in many areas. They were in lots of trees in the Paleozoic era, gymnosperms or cone-bearing plants, as well as other plants which died off, and then they formed the coal deposits, remember. So coal swamps were a vital part of the Paleozoic era. So that one's correct. It started off with the Cambrian explosion, we said that. And then birds developed during this era. Remember, this one is the odd one out. Right. Remember, birds and reptiles were part of the Middle Era, the Mesozoic era. So birds and reptiles characterized the Mesozoic era, where the dinosaurs were found. But the Paleozoic is where most of the forests and the algae and the plants were found. So therefore, the odd one out will be birds developed during this era. So for 1.1.5, the answer will be D. Let's now look at the other longer questions. Right. Here we're now talking about biological terminology. Remember, learners, the multiple choice and the biological terminology is where you can score your marks, provided that you have learned your work thoroughly and you've read your work over and over again. Remember that the more times you read and the more you repeat your reading on the sections, the easier it becomes for you to actually memorize the concepts without forgetting. Like for example, a telephone number that you use often, you do not need to look at it in the directory. Therefore, if you revise your work often, you don't have to freak out when you're studying, but the more times you read and understand, the better it is for you to actually answer your paper. Let us now look at the biological terminology related to history of life on Earth. What do we call turning into stone? Right, turning into stone, remember, when a shell or a bone becomes hardened from the calcium carbonate and the mud in the rock, it petrifies. So the word is petrification. Right, so that one is called petrification. The next one, a fossil in which the surroundings become stone. leaving a cavity where the body had been found. So you have a fossil which has an imprint, but the inside there is nothing. So which means the part on the inside is hollow, but only the imprint of it is on the outside. What do we actually call that fossil where something was there and then it decomposed, leaving behind an imprint? That is actually called a mold fossil. So this is called a mold fossil. Right, it's like having, for example, a chocolate put into different patterns on a tray, on a baking tray, and when you put the chocolate in and you take it off, you've actually formed a mold fossil. Right, so the surroundings become stone, leaving a cavity where the body had been, and that's a mold fossil. You can also call it a cast fossil. Mold or cast fossil. The time period and era. According to the geological column, when dinosaurs first appeared. Remember, the dinosaurs appeared in which era? You need to know the name of the era, and that is the Mesozoic era. So the dinosaurs appeared in the Mesozoic era. Right, the time period and era according to the geological column when the dinosaurs became extinct. And actually here, the answer has been given to you. It is the Cretaceous period. So the Cretaceous period of the Mesozoic era is actually, in that time slot, the Cretaceous period is where all our dinosaurs had become extinct. The dinosaurs became extinct because of the asteroid impact. The asteroid impact that actually caused volumes of dust, clouds of dust, thereby blotting out the sunlight. So in the Cretaceous period, which is part of the Mesozoic era, dinosaurs have become extinct. So it's in the Cretaceous period. And remember, the cause is the asteroid impact. Right, a person who studies the rock fossils. Person who studies the rock fossil is called the paleontologist. Here you need to be careful about the spelling. So it is P-A-L on paleon and then the tologist. Right, that is a person who studies a rock fossil. But a person who studies just rocks, remember, will be a geologist. Right. Layers of deposited material. Remember, when rock or mud is in layers, we call it sediments or sedimentary rock. So that is sedimentary rock. Layers of mud. No members of that organism exist anymore. We cannot find any dinosaurs anymore. They have now become extinct. So the word is extinct. And the last question, 1.2.8, the time era, according to the geological time scale, when mankind evolved. So when did man, as the first mammal, actually evolve? And that is the present era, which is actually the Cenozoic era. So we are present now in the Cenozoic era. So man or humans, the first humans appeared in the Cenozoic era. Right. Let us now look at the next question, which deals with the matching of the columns. Question 2, match. Right, match the terms in the first column with the phrases in the second column and write down only the correct letter next to the question number. So now, learners, remember, when you're dealing with a matching column, always try to organize the right answers on your question paper before you actually write down the answers on your answer script. In this way, you will be confident of your answers and you do not put the wrong answer in. Right, so let us now look at the matching columns. The Mesozoic era, remember that was the era whereby it was the middle era which is dominant of dinosaurs, and then we go to E. So we know that if you can make your pencil lines like that, so E is for the Mesozoic era, and then immediately you know that E is now for 2.1. The coelacanth, remember, it was a cartilaginous fish, and the coelacanth was a living fossil. Remember all the things that got to do with coelacanth: living fossil, cartilaginous fish, blue scales, had short legs, and it looked a little bit of an amphibian. It was a fish, and it had amphibian or frog-like features. So it's a coelacanth. Ancestor of frogs and fish will be the most suitable answer for coelacanth, and that would be A. Let's look at a therapsid. It's a reptile-like mammal. Remember the reptile-like mammal? So they had mammal-like features and reptile-like features. So therapsids, ancestral insect forms will be out. Solid fossils out. Superficial fossils, that one's taken. So the only answer will be, the most suitable answer would be, it had ancestral to birds and dinosaurs. So a bird is a mammal, dinosaur is more reptile-like, and therefore a therapsid will, sorry. Now you see what I've done. I've made a mistake. I said no, ancestral to birds and dinosaurs, but then I didn't see that there was another alternative. So these are the kind of mistakes that we can also make in the paper. We don't look at all the alternatives and we quickly put in an answer. So now we erase and we say no, there's another alternative. The therapsids, remember this reptile-like mammal had large palates and it had well-formed ear bones. Right, other reptiles did not have ear bones. Most reptiles don't have ear bones, but the therapsid had very large temporal bones or ear bones, and that was characteristic, a key feature of a therapsid. Therefore, therapsid, the most suitable answer was, because they had advanced palates and ear bones, the answer will now be H. Cast fossils, remember, they are solid fossils, so the cast fossil will be there, and that answer is C. And then you're going to look at trace of film fossils, not very clear fossils, just a trace of the imprint of an animal. So it's going to be very superficial imprints, and therefore your answer there will be D. Now you have your answer A, E, A, H, C, D, and you take those, put 2.1, 2.2, 2.3, 2.4, 2.5, and you then transfer your answers onto your answer sheet. Let's go to the next set of questions. We now look at some of the longer questions where the answers need to be in detail, looking at the most important facts as well. Let's look at question 3. Right, why is the coelacanth known as a living fossil? Right, what did we say? The answer was that about 350 million years ago, one of the professors recognized that this was a fish that existed 350 million years ago, and they have now found it again in the Comores in 1952, and then they found another, the first one in the waters of the East London Ocean. Therefore, it cannot be a fossil anymore. It is a fossil, but now because they refound it, it's now a living fossil. So we got to write down that the coelacanth is a lobed fish which was believed to be extinct for about 65 million years ago. So it means that although it existed about 350 million years ago, they thought it to be extinct about 65 million years ago. It was rediscovered in, it was rediscovered by the East London Museum in 1938, and then a second coelacanth was found in the ocean near the Comores Island. So where exactly would you get your marks for this question? That it's a lobed fish. It was believed to be extinct, but the fact that you have the word believed tells you that it's a fossil and now it's living. So it was a lobed fish that was believed to be extinct about 65 million years ago, and then the word rediscovered by the East London Museum, and then a second one was found, East London Museum in 1938. Then the second coelacanth was found again near the Comores Island. So by just saying what a coelacanth is, remember that it was a fish that also had amphibian features, but the fact that you can say that it was believed to be extinct and now rediscovered twice tells you that it's now a living fossil. Right, let's look at the next question. Question 4. Where here you've got to actually observe two images of fossils, and you can see immediately this is an imprint of an ammonite or a bivalve. Remember, ammonites and bivalves were actually invertebrates or mollusks, or they belonged to the family Arthropoda. Right, they were found in the sea, and obviously in the deeper layers of the sea, whereby they now, as the sea levels dropped, they stuck onto the rocks, and eventually the shells became petrified into the rocks. So that is actually an ammonite fossil, and you can see over here as well the shell structure of the ammonite fossils found in the rocks. Let's look at the question. Suggest three things that a fossil footprint like those in picture A. This is picture A, right? Picture A can tell scientists about animals that made them. So what can the fossil tell a scientist about the animals from which the fossils were made? Right, the first thing that a fossil can tell you, that means the scientist has to use deductive reasoning to infer, to conclude what are some of the characteristics of the animal from which the fossil was made. The first thing is to which family it belonged. Is it, for example, an invertebrate? That means it has no inner skeleton. Is it a vertebrate with a proper skeleton, like a dinosaur? Or was it a soft-bodied animal that left only the pattern of its outer shape onto the rock? So it can basically tell you to which species did an animal belong. So first of all, it will tell you the species to which the animal belonged. Right. That means it can also tell you whether it's a vertebrate or an invertebrate. It can tell you whether it's a vertebrate species. We mean, to which family did it belong? Is it a reptile? Is it a mammal? Then it tells you whether it's a vertebrate or an invertebrate. It can also tell you about the length of its leg and the speed at which that animal moved. So it can also tell you at the length of its leg, did it actually crawl onto the sand or did it actually walk onto the sand? So you're also looking at the length of the legs, and the speed at which the animal moves. Speed at which the animal moves. So those are the key things that a scientist can actually deduce from a fossil. The length of its leg and how fast it moved. It can tell you to which species it belonged. and it can tell you whether it was a vertebrate or an invertebrate, whether it had a soft body and an outer shell, or whether it had a body with an endoskeleton on the inside. Right. Okay, we go to the next question now. 4.3, explain briefly how this fossil was formed. Now, how does an ammonoid or a bivalve fossil actually form? Remember, to answer that question, we got to say that, first of all, the shell of the ammonoid, right, the shell of the ammonoid. So by identifying the fossil or the animal and saying which part of it was fossilized, it is the shell of the ammonoid became hardened. Remember, the word hardened is very important as part of petrification. Became hardened with mud. So you get a mark for hardened, mud, and the calcium carbonate from the rocks. From the rocks. The shell of the ammonoid became hardened with mud and calcium carbonate from the rocks. The inner soft body decomposed. So the inner soft body decomposed. So you're looking at 1, 2, 3, 4, 5, 6, 7, 8 marks. That is where you're getting your 8 marks. Right, we have now come to an end of the session on the history of life. Remember that the most important things are looking at the geological time scale, looking at the 2 eons, that they are the longest periods, and then your 3 eras, or your 4 eras basically. The first era where life originated, or the origins of the earth started, the Precambrian, then it went into the Paleozoic, the Mesozoic, and the Cenozoic. In the era where we are found, or man is found, is the Cenozoic era. Mesozoic, characterized basically by your dinosaurs and your reptiles and your mammals, your earlier mammals, and then your earliest forms of life, which is ancient life belonging to the Paleozoic era, which was characterized by your algae and most of your marine animals. So if you look at the geological time scale, remember those important facts, and then also remember what are the types of fossils, how fossilization takes place, the importance of fossil tourism, and some of the fossil sites found in South Africa. With that, it brings us to an end of the session. I wish you well in the exams. Please remember to study. The more you study or read, the better you will know your facts.